Hello, ladies and gentlemen. Today we are going to do Unit 10, Lesson 3. Let's make a little typo here. Unit 10, Lesson 3. We're going to talk about volume of prisms and cylinders. And today is just a lesson. There is no additional homework. So you're going to watch the lesson. You're going to fill in your notes completely. You're going to take a picture of your beautiful work. You're going to attach it to the team's assignment, and then you are going to submit your work. All right, and that's all you're going to have to do for today. All right, so I said when we started this unit, in order to calculate volume, you need to understand the concept of area. So first of all, we're going to get into what exactly is a prism. So a prism is a solid object with two identical ends and flat sides. The shape of the ends give the prism a name, such as a triangular prism. So this shape right here, this thing right here, that is a triangular prism. That is not a pyramid. That is a triangular prism. It has a triangle in the front. It has a triangle in the back that you cannot see. And then it has three rectangles that make up the sides. All right. Here we have a rectangular prism. You may call it a cube because, yes, it looks like it's a cube, but it is a rectangular prism. Here we have a pentagonal prism. We have a hexagonal prism, we have an octagonal prism, and we have a decagonal prism. So the cross section is the same along all of its length. So the cross section is like if you put a slice through it, parallel to what we call the bases. The sides are parallelograms, four-sided shape with opposite sides parallel. It's also a polyhedron. Okay, I'm not worried about you getting caught up in all of the vocabulary, but you should understand that when we talk about a prism, the two pieces that are the same size and parallel to each other, those are called the bases. Sometimes the base is in the front and the back. Sometimes the base is at the top and at the bottom. The distance between the bases is the height. So like in this example right here, this value, that would actually represent the height. And I know that's kind of weird because it's going from front to back, but it is the distance between the bases. Sometimes the height is vertical, all right? Sometimes the height is front to back. So the volume of a prism is quite simple. It is the area of the base multiplied by the height, where a height is the distance between the bases. Okay, and so that is very important for you to understand, because I mentioned you get a reference sheet. Okay, if you don't understand what height is, and that sometimes height goes front to back, you're going to get questions wrong. All right, B, this big B, this is a calculation. That's not just a single value from the diagram. That is a calculation that is the area of the base. Once again, you need to understand that sometimes the base is the bottom and the top. Sometimes the base is the front and the back. So sometimes when a big B is the area of the base, that's the area of a triangle. Sometimes it's the area of a rectangle or a square. Sometimes it's the area of a pentagon. That's why I said you have to understand area in order to do volume. Okay. So here we're going to start off simple. A rectangular prism. Okay. What is the name of the prism? This is a rectangular prism. Rectangular prism. It is not a cube because the edges are not all the same length. So we can look at this a couple of ways. We can look at the bottom as the base. So the area of the rectangular base is 4 by 3. So 4 times 3. And then the height would be 5. So the volume would be the area of the base multiplied by the height, which would be 60 centimeters cubed. Volume is in cubic units. That means that there's 1 centimeter by 1 centimeter by 1 centimeter cubed. It would take 60 of those to fill in this shape. Now, if you want to look at the volume in terms of, all right, let's look at the front and the back as being the base. So if the front is the base, the area of the base would be 5 times 4. And if the front were the base, the distance between the bases would be 3. So the area of the base would be 20 multiplied by 3. They would also give you 60 centimeters cubed. In this case, there's a couple of different ways to get to the same answer of 60 centimeters cubed. Example 2, we have a cylinder. Okay, a cylinder has a circular base, and the height is the distance between the bases. So when you do volume equals area of the base times height, B is not 3, B is not 6, it is the area of the circular base. The base has a radius of 3, the area of a circle is pi r squared, so you need to know that big B is not 3, it's not 6, it's not 9, it is 9 pi. That is the area of the circular base. Then the height is 10. Then you need to know that you're going to do 9 times 10 to get 90 pi inches cubed. And that is your answer. That is the exact answer. Now, if you're told to round, you would plug that into your calculators. Obviously, you should have your calculators out. So 90 times pi. And that's going to be, let's say, something like 282.74 inches cubed. So again, this is what you'll see on a reference sheet. You'll see big B times H. But if you don't know what big B represents, the volume is not going to help you at all. If you don't understand that height is the distance between the bases, this formula is not going to help you at all. You have to understand how to calculate the area of a circle. So you need to understand that this big B is pi r squared. Okay? It's not just about the formulas, it's about knowing how to use them and when to use them. All right. Here we have a triangular prism. You have a triangle in the front. You have a triangle in the back. Those are the bases. So the bases are the front and the back. So the volume is the area of the triangular base multiplied by the height, which is the distance between the bases. So you have a right triangle that has legs of 3 and 4 with a hypotenuse of 5. So the easiest way to find the area of a right triangle is to take your 2 legs, because if I were to rotate this thing, it would look like this. And you can do base times height, the base of the triangle times the height of the triangle divided by 2. So the area of the triangular base would be 4 times 3 divided by 2. The height, which is the distance between the triangles, is 8. So the area of the triangular base is 12 divided by 2 is 6. Multiplied by the distance between the triangles, which is 8. So that's 48 inches cubed is the volume of this triangular prism. Once again, you have to understand that big B is not just the number 5, not just the number 4, not just the number 3, not just the number 8. You have to understand that that is the area of the base. Now, I guarantee that some of you will look at this on a test or quiz and be like, Mr. Johnson, there's a rectangle on the bottom. Isn't the area of the base just 5 times 8? No. And when we talk about what's called a prism, the base are the 2 shapes that are congruent to each other and are parallel to each other. There is no other side that is a 5 by 8 rectangle. There's a 3 by 8 rectangle, there's a 4 by 8 rectangle, and there's a 5 by 8 rectangle. Then you have 2 triangles in the front and the back that are exactly the same size. Those are the bases. All right. Number 4. Find the volume of the figure below to the nearest tenth of a square inch. All right. It should be not square inch, it should be cubic inch. That's a typo because we're talking about volume. It shows a cylindrical tube with a hollow center. The outside radius is 6 inches, and the inside radius is 5 inches. And the height is 1 foot. So first of all, notice inches, inches, feet. Anytime you're calculating volume, area, you want to make sure everything is in the same units. So we're going to turn this all into inches because that's quite simple. We're going to make this say 12 inches. So kind of like what we saw with area, you can take a solid shape and then subtract out this inside portion. And you're going to be left with like a hollow cylinder. So the volume of the big cylinder, now the big cylinder has a radius of 6. So pi times 6 squared multiplied by the height. So that's going to be 36 times 12. You should have your calculators following along. That's 432 pi is the volume of the whole thing. The whole thing that is 12 inches tall and has a radius of 6. Now, we're going to take out the center. We're going to drill out the center of it. So that center cylinder has a radius of 5 inches and also has a height of 12. So 25 times 12, that's only 300 pi. So find the volume of the figure below. It shows a cylindrical tube with a hollow center. So we want to take the whole thing and subtract out the hollow center. So when you do 432 pi minus 300 pi, the pi's don't subtract each other. It's like doing 5x minus 2x. 5x minus 2x would be 3x, right? The x doesn't go away. So 432 minus 300 is 132 pi. All right. Now we're going to round to the nearest tenth. So we're going to do 132 times pi. So that's going to be 414. You better be following along on your calculator. 414.7 inches cubed. Okay? So a little bit of extra work there. You got to find two volumes and do a little subtraction. How are we doing on time? Not too bad, only 12 minutes in. Find the volume of the triangular prism below. All right. So we have a triangular base in the front. We have a triangular base in the back. Now sometimes, like you saw on the day 2 practice, you have to do a little extra work before you can actually find the area of your base. So when you're trying to find the area of this triangle, you're like, well, I got a base of 6, but I don't know the height. Well, we can see that this is an isosceles triangle. So when this altitude is dropped down, it's going to split this into 3 and 3. So now, and you probably recognize what kind of triangle this is, we have a hypotenuse of 5, we have a leg of 3, so you should hopefully recognize that by now as a 3, 4, 5 right triangle. So that altitude is 4. Now, if you didn't recognize that, you would just set up Pythagorean theorem, and you would solve for x, and you would get x to equal 4. So, what is the area of the triangular base? Well, the area of the triangular base is 6 times 4 divided by 2, because the triangle has a base of 6 and a height of 4. So the area of the triangular base is 6 times 4 divided by 2. The height is not 4. I know this is where it starts to get confusing. The height is the height of the prism is the distance between the bases. There's a triangular base in the front. There's a triangular base in the back. There's 12 centimeters between them. So the area of the triangular base is 6 times 4 divided by 2. That's going to be 12. The distance between them is 12. And 12 times 12 is 144 centimeters cubed. All right, one more down here. Fish tank is in the shape of a rectangular prism. Maybe some of you have a fish tank. I actually have It's not filled up right now, but I have a hexagonal prism-shaped fish tank. It looks like this. It is a 6-sided fish tank. It's only a 10-gallon, not very big. We set it up after COVID, and then after a while, it just started growing too much algae, so we got rid of it. We flushed some of the fish. All right, but when I was younger, I used to have a rectangular prism. That tank actually broke, so I don't have that tank anymore. So the 14 inches by 16 by 10. So let's say, we don't know. Let's see, this looks to be the longest. So let's say this is 16. Let's say this is 10. And that's 14. All right. Tank contains 680 cubic inches of water. What percentage of the tank is empty? Well, what's the total volume of the tank? Well, the base is 16 by 10, and it's 14 inches tall. So the total volume of the tank, this is where you follow along, 16 times 10 times 14, 2240. So that's the total volume. But you never fill a fish tank right to the top, because then it would splash out all the time. So you want to leave like a couple inches below the top of the surface. So it's got 1680 out of 2240. That's how much is in there. 1680 divided by 2240. So that's 75% is full, which means that 25% is empty. And there you go. All right. So these are the type of questions you should expect to see. All right. When it comes to readings exams, we are not simply going to give you a rectangular prism and say, hey, it's 14 by 16 by 10. What's the volume? That type of question is a middle school level question. All right. We are going to give you questions that require multiple steps. Whether it's you need to find a little something extra, like in example 5, to help you get the area of your base, or like example 4, where you have to find 2 volumes and you have to subtract them, or like here in question number 6, where you have to do a volume and do a little something extra after that. All right. These are the type of questions you are going to get. It's not going to be as simple as we give you all the numbers you need and you just calculate volume. Okay, that is middle school level mathematics. That is not where we are anymore. All right. Now, one application of volume is in the idea of density. Okay, and we're going to mix in density throughout this entire unit. Some teachers like to focus on density on one particular day or two. I like to continue to mix it in because I think it makes more sense to talk about it on a regular basis, and then instead of saving it all till 1 or 2 days. So density is the ratio of the mass of an object to the volume. So density is a ratio of mass over volume. So which has more density? So this is you probably have heard the question, what weighs more, a ton of bricks or a ton of feathers? And the whole idea is that someone will say, oh, a ton of bricks weighs more. Well, here's what that question is really messing with, is the idea of density. If you talk about actual weight, a ton of bricks and a ton of feathers is each going to weigh 2,000 pounds, because a ton is equivalent to 2,000 pounds. But if you think about how many bricks you need to make 2,000 pounds compared to how many feathers you would need to make 2,000 pounds, you would need thousands, if not millions of feathers, because feathers have very little density. They have very little mass to how much volume they take up, whereas bricks have much more mass in the amount of volume they take up. So that type of riddle, if you will, is more, the reason why it causes confusion is about the idea of density. So if you have 1 cubic foot of styrofoam, so if I have a 1 foot by 1 foot by 1 foot cube of styrofoam, and I have a 1 foot by 1 foot cube of concrete, and I say, well, which one has more density? Well, you have equal volume, but obviously 1 cubic foot of concrete is going to have a lot more weight, a lot more mass. And I know that those are not the same idea, All right, I know a science teacher would yell at me, but for the sake of what we're talking about, I'm going to pretend that mass and weight kind of represent the same idea. This 1 cubic foot of concrete is going to have a whole lot more mass than 1 cubic foot of styrofoam. So therefore, the concrete is going to have more density because it has more mass for the same amount of volume. Okay? Now, different metals have certain densities. So like pure gold, this is not me making, this is true. Pure gold has a density of 19.32 grams per cubic foot. This is how you can tell when you buy jewelry or if you take jewelry to a pawn shop. They will determine the purity of gold. All right, a pawn shop has a gold cube with a length of 3 centimeters. So it's a cube that is 3 by 3 by 3. Sorry, I had to pause for a moment. So the gold cube is 3 centimeters by 3 centimeters by 3 centimeters and weighs 503.75 grams. Is it pure gold? Well, here's what we know. The volume of this cube is 3 times 3 times 3. That's 27 cubic centimeters. It has a weight, or it has a mass, of 503.75. So the density of this cube is the mass of the cube, 503.75 grams, divided by its volume. And so what we want to see is, does this fraction equal 19.32? If it does, it's pure gold. If it's not, it's something less than pure gold. So pure gold, I believe, is 24 karat gold. Anything less, like when you buy jewelry in a jewelry shop or if you buy like a necklace, it's probably like 14 karat gold or 18 karat gold. It's not pure gold. There's other cheaper metals mixed in to make that jewelry. So get your calculator. 503.75 divided by 27, 18.657 grams per cubic centimeter, which I'm no genius. That does not equal 19.3 gold, 19.32, not pure gold. Okay? And that's it. So we're going to use this density function throughout this unit. So we got one more. In example 3, if the triangular prism is solid gold, what should its mass be? Okay, example 3, where was I? Example 3 is a triangular prism with a volume of 48 cubic inches. So let's just pretend, because it has to be in grams per cubic centimeters. So let's just pretend it's centimeters cubed. So let's say it was 48 cubic centimeters. And let's say it is solid gold, so that the density would have to be 19.32. If its volume is 48, then the mass, what should be its mass? So if it has a volume of 48 cubic centimeters and its density has to be 19.32, well, you put this over 1, you cross multiply, and 48 times 19.32. So its mass would have to be 927.36 grams. So if it had that mass, then yes, it would be pure gold. Okay? So, gist of today, volume of a cylinder, area of the base multiplied by the height. A volume of a prism, area of the base multiplied by the height. Cylinder has a circular base multiplied by the height. Keeping in mind that the height might be a vertical height, height might be a front to back value. It's the distance between the bases. When you're calculating big B is the area of the base. It could be the area of a triangle. It could be the area of an octagon. It could be the area of a hexagon. It could be the area of a rectangle or a square. And then we're going to see density equals mass divided by volume throughout the rest of this unit. All right, so that's it. So make sure your notes are full. Take a picture of your beautiful work, send it to me in the assignment, and you are all set for today. Thanks, guys.